was saying, as Scott alluded to, the Middle Peninsula Planning District Commission has worked with the Virginia Port Authority and VIMS to start looking at a regional approach to dredging in order to facilitate getting these projects done. So my 6-word story was the shallow draft dredging supporting coastal communities. Having safe boating access is crucial to coastal communities, and that's through supporting the seafood industry, the property taxes, marina and boat taxes, day trip expenditures, etc. It's very important for the boating community to have safe access to their harbors. So generally, what are shallow draft navigation projects? They're defined by the Corps of Engineers. They're channels that are maintained to depths that are shallower than 14 feet. They have low commercial use, less than 1 million tons a year, and they also may provide a safe harbor of refuge. Beginning in 1884, they started dredging in the lower Chesapeake. And in the 1950s and 1960s, they established channels throughout the bay to support the seafood industry to allow safe passage for boats. Each channel is unique in terms of their tidal hydrodynamics and boating requirements. And channel dredging is needed when you need safe navigation into and out of the creek, be able to access the channel, or when the shallow navigation waterway is impaired. So I'm going to be talking about 2 of the shallow draft channels that we have been looking at for our study. And these are Timberneck Creek and Aberdeen Creek. They're 2 lateral creeks that enter the York River from Gloucester County. Aberdeen Creek is actually a federally defined navigation channel that extends from the York River into Aberdeen Creek. It was established in 1962, and it has channel dimensions of 1 mile long, 80 mile wide, and it has a controlling depth of 6 feet, and it has a turning basin near the working waterfront. The working waterfront is a set of piers, boat ramp, supporting buildings. They vary depending on where they are and what their usage has been over time. And this channel was dredged in 1962 and in 1974, but there hasn't been any maintenance dredging since 1974. Timberneck Creek is not a federally defined shallow draft channel. This is one that the county identified a need to support the working waterfront in the creek, as well as the new state park, which is located on Timberneck Creek. And through the process of this project, we proposed a channel that was designed to extend from the York River 7,200 feet to the working waterfront. It would be 80 foot wide, 6 feet deep, with a 160 foot turning basin. And we used survey data, which we'll talk about later, but it used that information to follow the natural channel as much as possible to design a proposed channel for this. Because this is not a federal channel, this channel has never been dredged. So for this project, we collected a lot of data for all of the creeks that we were looking at. We hired a survey company. We partnered with them for this project for the surveying and the engineering, and they collected survey data points. A lot of survey data points. They were like 10 feet apart on 100 foot spacing for the lines. We took that information and we created DEM with a 5 foot grid spacing. And we used that information to determine where shoaling is occurring within the channels and how much material will need to be dredged. And so we were able to calculate volumes using our survey data. And these are the 2 channels, Aberdeen and Timberneck. And the red shows where most of the dredging will occur for each of those channels. For both of them, up at the working waterfront are the areas that need the most dredging, with the exception of at Aberdeen Creek, which is at the mouth. It's shoaled right where that turn is. Using this survey information, we would have to dredge about 46,000 cubic yards from Timber Neck and about 59,000 cubic yards from Aberdeen Creek. And so we took the information, we were able to develop cross sections for each of the channels. And the dashed line is what the bottom looks like in the cross section. And the cross sections are shown on this. They extend across the channel at different locations. And so for AA, you can see up at the turning basin that the turning basin is almost completely full and it needs to be almost completely dredged. And at B, which is right at the turn, it also has almost full up and will need to be dredged almost completely. And then you can see the remnant in C of what the previous channel was and what needs to be dredged now. And Timber Neck has not actually been dredged at any point. And so we used, as best we could determine, the natural channel through the creek. And these show where the dredging will occur, and that most of it will have to be a fair amount of dredging. So also, in addition to that, we collected additional data. Two of the most important things you need to know when you're planning a project, and that is that you have to know how much material needs to be dredged and what kind of material it is. And so we collected cores, and we also collected chemical samples from 2 locations. We took 6 to 7 cores throughout the channel for each channel. And those cores were split, photographed, described, and sediment sampled for grain size. And if you look from the inside of the creek out to the York River along a line through the center of the channel, we plotted where those cores that were taken actually occur. And if you look in the middle, you see the brown line, which is the dredge depth. And that would be the amount of material and the type of material that would have to be dredged through that channel. And this is Aberdeen Creek. And as you can see, there's very little sand in most of these cores. That they're only the AC4, which is right at the mouth, has 98% sand. All the other ones have less than 90% sand. So the standard for being able to put dredge material along a shoreline as a beneficial use is that it has to be 90 to 95% sand, and it also has to be larger than 0.25 millimeters, which is sort of the medium fine sand break there. So you need medium size sand or above in order to be able to put these. So because this grain size is too small, it's going to have to be placed in an upland disposal area. Timber Neck is the same thing. It has almost all silt and clay that would be dredged from the dredge channel, and it needs to be placed in the upland disposal area. We also took chemical analysis. There was no indication at all that any chemical contamination occurred, but because this will be placed in an upland disposal area and potentially end up, as other uses or in a landfill, we sampled for just standard chemicals that could possibly occur. And what we found is in none of our creeks, we've sampled 7 creeks throughout the Middle Peninsula, and none of these had any of these metals or the hydrocarbons or the pesticides or herbicides in them. So when we talk about where material is going, for Aberdeen Creek, it's a federally defined channel that's already been dredged twice. And in the past, the material has been placed along the shoreline. It had upriver a large plot of land that was the owner allowed the material to be placed there. and that occurred in 1962 and 1974. How nowadays, if you look at that same parcel of land, it's mostly marsh, and being able to place that material there, while it could possibly be permitted, most likely it would be a challenge to get it to be covering so much wetland. So we had to find an alternative in order to where to put the material. So upriver from Timber Neck Creek and adjacent to Aberdeen Creek, the Department of Conservation and Recreation has property that was donated to them, originally for a Middle Peninsula State Park, but once the other property became available, this has it's not going to be used now as a state park, to the best of their knowledge. But they're willing to support the effort of these dredge material. And so we've looked at several different options in order to be able to place the dredge material in an economic, environmentally safe way. And one of the things that we're looking at are geotubes. These are used around the world for a lot of different types of projects. And what you can do is you pump the material into the tube, and then you form a dike around the outside, and then you can put material on the inside. And that makes it very economical because you can use the material to fill the tubes, and then you have additional space for additional material inside the dike. And so this is where we've looked at placing. And if you build a conventional disposal area, it's outlined in yellow, and the size would be too large. You'd have to have like 30 acres in order to hold all of the material if you just dike it up with sediment on site. But if you use the geotubes, the orange outline, that shows a combined disposal area for the three creeks that are close to there: Timber Neck, Cedar Bush, which is in between Timber Neck and Aberdeen, and then Aberdeen Creek. You could fit all the material into that footprint. And the pink shows that only the Aberdeen. So estimated cost with Aberdeen Creek, the dredging would be about $1.2 million to be able to maintain that channel. Timber Neck was 1.1, and then to build the combined disposal area, you would have about $900,000 in pumping and geotubes, and then also whatever site prep you'd have to do, such as any clearing of woods or building of roads to access the site and that sort of thing. Additional work that's being done on this project on the Middle Peninsula is we've identified all of the tidal creeks on the Middle Peninsula and collected their physical parameters into a database. We also collected this detailed level of analysis and project design for the 7 channels. We've also started looking at 15 additional channels for scoping level, which is just sort of taking augers to trying to get what kind of grain size and some bathymetry. Also, a business plan model is being looked at to try and figure out the best ways to do the dredging, how to save money, and also looking at alternative disposal methods. And that's all I have. So if anybody has any questions.